Hello and welcome to RollCyber's webinar series. My name is Ahmed and I'll be co-hosting today's session with my colleague Lohit. I will now hand over to Lohit for a brief introduction before we start.
Thank you for the introduction, Ahmed Said. Hello, everyone. I'm Lohit Duradla. I work as a data scientist at Royal Cyber. I'm very much excited to take you through a live demo later in the webinar today. Back to you, Ahmed.
Thanks, Lohit. We are thrilled that you're joining us today as we share our thoughts, insights, and best practices drawn from our experiences in assisting organizations transform their business operations using data, analytics, and AI services. Before we dive into today's exciting topic of implementing semantic search for e-commerce stores, I'd like to quickly go over two short and simple ground rules. First, if you're unable to hear or see the presenter screen, please use the raise hand button or leave a comment in the Q&A section. And secondly, we highly value your thoughts. So please put your questions and thoughts in the Q&A section as they arise. We aim to address as many as we can today at the end of the presentation, and we promise to follow up on any that we can't get to today during our time together. With that out of the way, let's dive into our content for today. We have designed a lean agenda for today. I'll begin with a quick introduction to Roll Cyber, followed by outlining a brief backdrop on the importance and relevance of on-site search and its relationship with key business metrics for an online e-commerce store. We'll then move on to discuss Roll Cyber's six-step solution to implementing semantic search for your e-commerce store. I will then set things up for Lohit to walk us through a live demo where he'll be using publicly available e-commerce dataset and walking us through our six-step process as we explained before, and then we'll open up the floor for questions and answers. So just a bit about Roll Cyber. Roll Cyber is a global IT consulting and digital transformation company specializing in services, solutions, and software. We have over 600 plus happy and satisfied customers spanning across 10 countries and supported by a skilled team of over 2,000 plus role Siberians who are ready to help you with your digital transformation and business optimization journey. Next, we'd like to provide a backdrop to illustrate the evolution and importance of optimizing site search within the context of an e-commerce business. We know that site search has been a journey of evolution and revolution for e-commerce companies. We've come a long way since the early days of e-commerce search, from CompuServe's electronic mail to ordering Pizza Hut online. From the early days of Amazon.com selling books to being one of the top 5 sites used globally, where search is ranked as one of the top 3 factors that determine customer satisfaction, all the way to the modern day sites, where some solely rely on on-site search as their primary method of navigation. Site search also has a hidden power. It boosts sales and metrics. Site search is the primary driver of performance KPIs. The chart here shows the contribution of site search to the top 3 KPIs for most e-commerce sites. As you can see, it drives 65% of the internal traffic and is a major contributor to revenue, as much as 35%, based on research provided by Algolia, who powers internal site search tooling. Research also underscores a marked rise in conversion rates. So here we're comparing websites where they did not have on-site search before, and then they implemented an on-site search solution. And you can see the top 3 brands, along with within the e-commerce band across the world: Amazon, Walmart, and Etsy. And we can see their conversion rates have seen a market increase after the on-site search was introduced, which is pretty remarkable. Customer loyalty, brand value, and SEO. Um, they all have a direct correlation with search performance, as shown here. For example, within the Net Promoter Score, we saw 78% of customers were more likely to recommend a brand with good site search experience. We also saw search relevancy was increasing NPS by 15% by 15 points. We also found 61% of customers citing positive brand perception when searching for a product or service through an optimized site search. And within our research, we've also seen a reciprocal increase in SEO, purely as a byproduct of having a properly crafted site search experiences. These are all really profound metrics. If you are in e-commerce or any business, metrics like that are really important to drive the performance of your business. But here's the catch. Not everyone is taking advantage of site search. You know, lack of optimized site search leads to a reduction in key metrics as well, such as in our research and work, we have seen about 60% of customers saying that they would consider switching brands if they found a better site search experience elsewhere, or more direct impact, such as drop in site traffic, cart abandonment rates, and reduced conversion. What that means is that retailers are leaving money on the table by not optimizing for their site search. Some of the research we've conducted, again, shows as much as 15% revenue lost purely attributed to a poor on-site search experience. But not all is doom and gloom. In our work, we have turned around the on-site search experience for many retailers to help them claw back on revenue lost due to poor search, as much as 15% in some cases. And we envisage another 15 to 20% estimated improvement in e-commerce revenue by the introduction of semantic search when done correctly. This is a profound increase. And as much as it might sound too good to be true, it's actually possible to make it happen. Because we know that at a high level, um, semantic search aims to address the limitations of keyword-based approach that typically leaves the user with a poor experience. Now, let's see how semantic search can address these limitations and help you improve your online store. Let's take a look at our six-step building block solution to implement a large language model driven semantic search. Now, after evaluating your current search experience and technical environment, we will work with you to identify which datasets will best help you achieve your goals. We will then identify the best language model. For our demo here, we're using a tailor-fit, albeit smaller, language model called All Mini LM L12 v2, which is hosted on Hugging Face repository and is runnable online, no hard installation required. We'll be using the LangChain orchestration framework, which is like the glue that chains different aspects of model building in an extensible way, such that it acts like an integrated system. LangChain provides different modules as listed on the right, each serving a distinct purpose and enabling sequencing of different tasks. For our demo today, we'll be focusing on the data connections component, which enables loading documents such as your proprietary data, creating large language model text embeddings, and loading the vector databases. We will then choose the right vector database for you, a database that stores vector values, which is a far better way to efficiently store contextual relationships and meanings of words compared to a traditional relational database. We will then use a compute layer, and again, based on your existing or preferred tech stack, along with the model management strategies using best-in-class large language model ops toolings and practices. This will include model versioning, metadata management, inference point configuration, and a detailed telemetry on model performance and optimization. And finally, we'll help you deploy the large language model solution in your existing infrastructure and work with you to create an iterative feedback loop to see how this is impacting your customer experience, measured through underlying key agreed upon metrics. Now, when it comes to loading data, you can choose from any data type. It could be structured, it could be unstructured, and any storage facility where you already have your data sitting. So it could be on-prem, cloud, a mixture of both, or within a data lake or data warehouse solution, or a NoSQL database. We will then help you choose the right embeddings and the large language models. Now, there's a range of choices out there with each with a different strength and weakness. So depending on your use case, we'll work with you to understand your requirements and choose the right model for you. Here you see, some of the top large language models and providers, and as you recently heard, Apple is also coming up with Apple GPT, which will be really exciting to see. But these are some of the models that are used in the industry as of today, and there's some of the providers that we listed, but there's many, many more that are coming in the market pretty much each day. Now, irrespective of the model we choose for you, I'd like to provide a high-level, bare-bone overview of how it will work with your data sets. So firstly, we'll load the most suitable data set in batches. This is to ensure that we are optimizing for cost. Your data will then be converted into vectors, which is a mathematical entity that represents various dimensions of an object, such as a quantity with both magnitude and direction. Vectors are commonly used to describe physical quantities that have both size and direction, such as displacement, velocity, force, or acceleration. In our demo, the language model we've chosen provides about 384 floating point values, or dimensions, for each word or token. Here, we demonstrate how each of the words, such as office and chair, um, are converted into a vector with 384 values, and how we can then imagine them in a vector space with all the other words in your product catalog, calculated by their distance from each other. There are many methods to calculate distance between vectors. Here, we're using a metric called cosine similarity, which means that the closer the vectors are to each other, the more similar they are. In our demo, we'll be using cosine similarity loss function, which is an objective function that optimizes the model's vector representations by minimizing the dissimilarity between the predicted and target vectors. So what it means is that in the demo, the lower the score, the closer the vectors would be to each other. Now, we'll show you a high-level overview of how, um, well, here we'll basically help you choose the correct vector database. As shown, they're available both within the open source and enterprise solutions. And we're seeing many traditional databases such as Postgres and Cassandra providing support for vector search, which is great news for the community. Now, we'll show a high-level overview of how vector databases power semantic search for an office furniture company. Say you search for a black leather chair. You'll be shown the most relevant image of the product that you asked for, followed by a list of semantically similar products such as the chair mat shown on the top right, or the black office leather couch, the relevant cleaning products, and even office decor accessories such as the indoor office plant. A vector database provides us with the storage of the embeddings that the large language model creates against your data. It provides the indexing, and it also provides the document retrieval, which makes it a really powerful asset in the implementation of a large language model. As covered before, we can deploy these models within your existing infrastructure. We work with all major cloud providers, including multi-cloud environments, and also support on-prem solutions. With regards to model management, registry, version control, and the overall inference strategy, we work with a range of providers. And in this demo, we have chosen Databricks infrastructure hosted on Azure as our compute, and MLflow hosted within the Databricks environment as a managed services to track the models, the registry, and the inference point solutions. And lastly, we'll be seamlessly deploying our solution within your existing e-commerce stack to enable powering a variety of customer queries and use cases, all supported through one infrastructure, which makes this a really powerful and scalable solution. Here we see a bunch of possibilities that you can imagine. You can imagine a customer providing you with an image of an office chair, um, or an image of their office or their home office, and asking questions to get a semantic answer. They can also extend the conversation by asking what else goes with the office chair. Um, or they can be asking other relevant questions like how can they find more space-saving furniture options for their home office. All that is possible through the implementation of large language models as described here today. Alrighty then. Um, Time to dive into a short live demo where Lohit will be using a publicly available e-commerce furniture data set within the Databricks environment. He'll be using LangChain framework, Chroma database as our vector DB, MLflow as our MLOps engine, and rendering the output using Streamlit as the front end. Well, we hope that you'd enjoy and see the relevance of this demo within your business, and I will see you shortly after that.
Now let's get started with our demo. So in this demo, we will be using two different notebooks. In the notebook one, we will be using a base model wherein we will be directly generating embeddings on our data. In the second notebook, we will be first training the model with our data set, and then we will be generating embeddings on top of it, which will increase the model performance. Therefore, notebook 1 is the base model notebook, notebook 2 is a fine-tuned one. So let's start. So firstly, we will be importing a couple of packages. We will be calling our config file. And then in the next step, we are defining our path in DBFS so that we can save our data sets. And then we can use it later. Now, let's have an understanding of our data. So we have three different data sets for this demo. The first one is product data. Let's understand the different columns in it. So in this data, in the products data set, we have few columns like product ID, product name, and each of the product name is again categorized into a product class. And then we have category hierarchy as another column. And we have the product description, which gives you an understanding of what the product is. The next column is product features, wherein some specific features to a product would be added in this, like the color of a chair, weight of a chair, or the dimensions of it, etc. And then rating count, average rating, and review count. Now let's move to the second data set, which is nothing but the queries data. So we have a unique query ID, we have a query, and then we have a query class in it. This is about the queries data set. Third data set is the labels data set. In this data set, we have few columns like ID, query ID, product ID, and label. So this is it. This column signifies the relevancy between the query and the product and its descriptions. So we will be using this column to fine tune our model performance in the second notebook. Now, in the next step, we are actually assigning a score or a numerical value to the different categories available under the label column. So what we are saying is wherever we have a category called as exact, replace it with a value as 1. Wherever we have a category as partial, replace it with a value for 0.75. Wherever we have irrelevant, replace it with replace it with 0. So we will have a new column called label score, which we'll be using in our second notebook. Now, I'll jump on to show you the final output of our demo, and then I'll again come back to the notebooks and walk you through the different steps we have used to achieve the output. This way, you will have a better understanding of our end goal. So here I'm using a Streamlit UI to input a query and then get the desired output. Now this is the query that I've entered. Now let's wait for our results. So you can see we have few results here. Now in the output, we have 4 columns and 5 different outputs. So we have a product ID, we have a product name, we have a product description, and we have a score associated to it. Now let's understand what does the score mean. This score is nothing but a cosine distance score, which is used to identify the nearest neighbor. The closer the value to 0, the better the recommendation is. The closer it is to 0, higher is the relevancy between the query and the result. So now we can see that for farmhouse dining room table, Lemont dining table is the closest or the best recommendation, and homestead dining table is the second best recommendation. So on, we have got 5 different results as I have restricted the results to top 5 searches. This is how we have an output. Now let's jump back to our notebooks and see how we have achieved this output. Now in the next steps, we will be installing few packages like sentence transformer, LangChain, ChromaDB, typing inspect, and typing extensions. Once we have installed, the next step is to import our packages. So we are importing the sentence transformer model from sentence transformer package. In a similar way, we are also importing the data frame loader from LangChain.document loaders. We are also importing the Hugging Face embeddings from LangChain.embeddings. And we are also importing the ChromaDB from LangChain.vector stores. We are also importing the ML flow. Now the next step is to generate embeddings. In order to generate embedding, the first step is data preparation. Now let's see on what are the columns that we will be using to generate the embeddings. So from the products data set, we are selecting the product ID, we are selecting the product name, and we are selecting the product description. So we are selecting these 3 columns in order to generate the embeddings. So here, if you see what we are telling us, wherever we have description, use it. And if we do not have a description for a product, then use the product name itself and then rename the column as product text. So here we have a product ID, we have a product name, and we have a product text related to it. So we will be generating the embeddings on our product text. So now we have our data set ready, and let's see on the next steps. So in order to do a basic search, do a query and get the results, what are the steps that we need to follow? The first step is to download our model. And then the next step is to load our model as Hugging Face embeddings object. Third step is to assign a path to a chroma DB, and then we will be generating the embeddings. So let's see on the first steps. So here, first we are downloading our model. So from the sentence transformer framework, we are downloading the all mini LM L12v2 model. Now we are assigning path to our model so that we can retrieve it in the later stages. And then we are actually loading our model as an Hugging Face embeddings object. In the next step, we are again assigning a path to save our chroma DB, so to save our output in the chroma DB. And what is a chroma DB? So basically, chroma DB is used to store the embeddings that are generated from the model. Now we have a path to our model. We also have a path to our chroma DB. In the next step, we are using a function called data frame loader, which converts your data in a format that is required by the model. So you can see that it is using the product text to generate the embeddings. In the next step, we are passing the documents, which is nothing but the data. We are passing the model. We are also telling about the path where we need to save our embeddings. Once we run this, our embeddings are now generated. Now let's see on how the embeddings look like. You can see for one row of data, we have 384 different values like this. And this output is just for one row of data. So you can see we have under metadata, we have the product ID, we have the product name, and for this description, we have the embeddings in this format. Now, once we have our embeddings generated, we can now do a basic search and get the results. So I'm using a function called similarity search with score from the vector DB, and I'm passing in a query as kid proof. And these are the results which I've got. I've got close to 4 to 5 results, and let's understand them. So I have metadata wherein I have the product ID, I have the product name to it, and under page content, I have the product description to it, and also a score. This score is nothing but the cosine distance score, which we discussed a while ago in the output, which I showed you on this Streamlit. So you can see that the scores are not that great, as here we are actually just generating the embeddings on the data. Here we are not training our model with the data set. So these are the scores which are not closer to 0. It means that the model is not performing that great. So now we have 4 different outputs. We have 4 different recommendations for our similarity search. Now, once we have an output like this, we will next log our model to the ML flow. This is for model management. So there are certain steps that we need to follow in order to log our model to ML flow. The first step is that we need to define a wrapper function. The second step is we need to define the model artifacts path. Third step, we need to define the model requirements, and then we would be persisting model to ML flow or saving the model to ML flow. And then if everything is good, we will then push the model version to production stage. So let's understand. So now here we are actually defining a wrapper class of our model. So what do we mean by that? So the purpose of a wrapper class is basically to provide a high-level interface which makes it easier for the user to use the model. They are basically used to abstract away the complexity of models implementation details, making it a more user-friendly. Here, we have also defined a predict function through which the user would do a query. And then we have also defined some steps that how do we need, in what format do we need the output, and what are the columns that we need in the output. So here we have also mentioned that we need the product ID, we need the product name, we need the product description, and we need the scores as output, as we have seen in the demo which I showed you. So we have a wrapper class ready now. Next step, we will be saving our model artifacts in path. So we are talking about our model, and here we are talking about a chroma db, and then we are passing and we are saving it in a particular path. So once we have the artifacts path ready, next step is to define the environment requirements. Here we are actually mentioning about the packages that we have used and the versions that we have used for the packages. In the next step, once we have our artifact path ready, we have our product search wrapper ready, we have our Conda environment defined, we will then log our model to the ML flow. In the next step, once we have the logging done, we will push our model to the production stage. So in this case, we are mentioning that we want the latest version of our model. This is because we may have multiple versions of our model with minute changes. We can have version 1, version 2, version 3, and so on of our model. So here, what I'm telling is use the latest version and then put it into the production stage. Now we have put our model into the production stage. Then next step is to retrieve the model and then test it. In the next step, we are actually retrieving our model from the registry. This is nothing but the path. We are retrieving it from the registry, and then in the next step, we will be doing the testing of our model. Here, I'm using this predict function, and then I'm passing the query to this function. This is nothing but which we have written in the wrapper class. So we do a search. Now we have 5 different results. So for a farmhouse dining room table, we have a product ID, we have a product name, we have a product description, and we have a score associated to it. So you can see we have got recommendations as Lemon dining table is the best dining table, is the most relevant to our search query. And then we have rustic dining table, we have Montauk Pine Solidwood dining table, and we also have scores associated to it. But you can see that these scores are not that great and they are not closer to 0. It means that we can actually improve the model performance. Now, this is what we have understood from the base model. Now, let's see in our second notebook on how we fine tune our model and how our performance would increase. Now, let's fine tune our base model. So how do we do that? So we first train our model on the data set. And in the next step, we will be generating embeddings on the same data set. So let's get started. First step, we are again installing all the packages that is required. We are then importing our packages. We're then calling our config file. And the first step in this would be to prepare the data in order to fine tune our model. For doing that, we are performing a join on the products dataset, the labels dataset, and the queries dataset. On doing so, we have an output of 3 columns. One is the queries column, one is the product text, and we also have a score associated with it. Now let's understand the significance of these 3 columns. So here we are trying to show the relevancy between a query with respect to a product and its description. And this score is nothing but a relevancy score to it. So here we are trying to tell that for each query and a product description pair, this is the relevancy score associated to it. Now we have a data that we need to pass into our model, and then we would be downloading our model. Next step is to restructure the data. So we have the data set ready, but we need to prepare it in a format that is expected as an input for the model. So for this, we are defining a function and then passing our data in it. The next step is to fine tune the model. Here we are using a function called data loader, which will take our data set as an input. We are also defining a loss metric, which is nothing but cosine similarity loss. And in the next step, in .fed function, we are passing the data and the cosine similarity loss. And now we have fine-tuned our model. Now let's estimate the fine-tuned model performance. In order to do so, in a similar way where we have done in the first notebook, we need to generate the embeddings. And for that, we need to prepare data. And these would be the same steps that we follow in the first notebook. First would be the data preparation for model input to generate embeddings, and then we would be loading our model as Hugging Face embeddings object, and then we would be generating the embeddings on our product description. Now, since we have the product descriptions ready, let's test our fine-tuned model. Yes. Now let's pass a query, the same query which we have used in our previous notebook so that we can do a comparison. Now I have again passed farmhouse dining room table. Now we have an output with 4 columns in a similar way. Now we have product ID, product name, product description, and a score. Look at the score. Now the score has drastically come down and it is much closer to 0, which means that the recommendations are very much better, which means that the recommendations are very much relevant to the query. You can see that the performance has increased. Let's compare it with the first notebook output. This is the first notebook, the base model output. You can see the scores were 0.39, 0.40, 0.41, and so on. But now you can also see there are a few recommendations that have actually changed in the second notebook. And also you can see the values have also changed and they're much closer to 0 now. Now, once we have our model finalized, we can then go to the deployment. Since we have already logged our model in the ML flow, we can then move to the deployment. The next step is to create and deploy the endpoint. The steps associated with it are, you need to first check the same models. Then you would define the model serving configuration. Then you would create the endpoint. And at the end, you would test the endpoint. For that, you would first import few packages and then review the model names because there would be so many models that you might have used or tested. In order to have a proper understanding and to make sure that you don't mess it up, you would first need to review the model names so that you can select the appropriate one. Next step is to select the model. Once we have done that, we need to define the model serving configuration. That is the type of cluster you want. You need to mention the model name. You need to mention the experiment name. The next step, once you have finalized your configurations, your model name, your serving endpoint, you need to create your model serving endpoint. Now you have created your model serving endpoint, and then the last step is to test the model serving endpoint. This is a bunch of code that is basically required in order to test your endpoint. So you mention the model, you mention the endpoint URL here. You create a scoring function through which you pass your query, and then the user will be getting the output. Now we have seen on how to log our models to ML flow and deploy or create our endpoint through the notebooks. Now let's see on how we can achieve the same thing through the Databricks UI. Generally, whenever we run our model, a new run is created and each run is saved under an experiment. We can have multiple runs under the experiments. You can click on this option. This will in turn open a new window where all the experiments are saved. So We have two different runs. Let's select one of them. And then in turn, you would have a window, something open like this. Then you can see that we have a tab here called parameters and metrics. Generally, for the machine learning models, there are some parameters associated to a model. When we run that, those parameters are generally logged here, and also the metrics of this model are generally logged here. But because we don't have any, we did not log them here. And then you can also have a look at the model artifacts. You can click on ML model. You can see that we have the cluster runtime also specified here. You have the ChromaDB path and the URL. You have the your model embedding model path and URL specified here. Then you can click on Kunda.yaml. You can also see all the dependencies, the packages that you have installed, and also the versions of it. And then you also have your pickle file created. You can also see that you have your serialized version of your model, and then this is nothing but the requirement txt file. So you have everything saved here. Once we have checked all these, and if we are okay to move forward, we generally save it, and then we move to the models tab. The models tab, you will find different models that are actually saved, and then let's click on our saved model, FineTune search. You can see that we have two versions of it. So basically, I have run it twice and I have had some minute changes in it. So I have two versions of the same model. And my latest version is version 2, which is already in production. You can see here, we have an option called stage, where we have three different or four different options available. So one is none, one is staging, one is archived, and one is production. So none is, it means that the model is not in any state. It is not in any stage. Staging means it is in the testing phase, and archive means it is in sleep mode. And the next option is production. So also you can see we have two different options. One is request transition to, one is transition to. So transition to is directly the user can change the stage of the model. And when you click on request transition, it generally sends a message to your superior, that could be your manager, that you're doing a transition of your model, that is from either staging to production or archive to staging, and then he will be intimated accordingly so that he also has an idea on what is happening with the models. So since I've already put my model into production, we can now go for model inferencing. Once we click on use model for inference, you can see your model name here. You need to select the version, since ours is version 2, and you can actually give your endpoint name, and then you can select the compute version. For our use case, I've already selected the medium. Depending on the requirement, you can select the compute here. Once we have done that, we then need to move to the serving option available here. So you can see LangChain search 2 as our endpoint name. You can click here. You can see that the compute is mentioned as medium, our state is ready. We have our endpoint name. We also have our model name here, and which we have also mentioned the version. Now you can do the online querying from here. Click on query endpoint. You can pass your query here, and then in turn you would get the response in this box. So this is how you can also use the UI to do the querying and check the results. So I am pretty much done with my demo. Thank you very much. Over to you, Ahmad.
Thanks, Lohit. It was amazing to see the search relevancy increasing dramatically between the off-the-shelf and the fine-tuned model. I can only envisage the ROI benefits of doing this at scale for our prospects and customers in e-commerce and related domains. So, just to summarize, e-commerce businesses are leaving money on the table due to subpar on-site search performance, and we believe that a tailored end-to-end semantic search solution will not only help claw some of that revenue back, but would also add to the order of an additional 15 to 20% on top by showing contextually relevant products, increasing conversions, and turning visitors into loyal customers. Royal Cyber can help you get started with an exclusive offer for this webinar by providing free consultation and access to jumpstart packs starting from $0. So feel free to reach out to us to discuss further if you wish. With that, we conclude our webinar and thank you all for your time again. We see some questions come through, so we'll now be opening up the Q&A forum. Thanks, everyone.